Let's take one more example about how can we find the volume using cross-section. One of the famous questions also on calculus, that how can we find or how can we calculate the volume of a given pyramid. The question said that Giza pyramid height is 152 meter with a square base of 230 meters height. Use the integration to find its volume using two different ways. So let's consider that I have x-axis and y-axis inside the pyramid. Vertically inside the pyramid here, I have one axis. It's not straight but supposed to be straight, and this is the second axis. Suppose that this one will be x and this one will be y. If I take the cross section, this will be the x-axis and that will be y-axis for the pyramid. The question said that the height of the pyramid is 152 meters. So I'll put the height over the x-axis, so that point will be 152. And its coordinate will be 152 for x and 0 for y. If the x-axis is at the middle of the pyramid, it will bisect the base of the pyramid into two equal parts. So the base of the pyramid is equals to 30. So each side will be 115. So the upper will be 0 for x and 115 for y, and the lower will be 0 and negative 115. So this is the base for the pyramid. The side edge of the pyramid is connecting the 2 points together. This will be the vertical cross section. If I refer back to the question said that the base of the pyramid is a square. This means that if I make any cross section, whatever, at any point x and y, like this one, this cross section will be square. But I should decide the length for each cross section. So suppose that I drew the cross section here. It will be a square. Let's graph that square. This will be the cross section of the pyramid. We learned that the volume using integral equals to integration from a to b of area of cross section regarding to x dx or dy. So the first step I have to decide, I will use dx or dy. At the cross section, if that section is perpendicular to x, you should put your integration with variable x, and if that cross section is perpendicular to y, you should use the integral of dy. So now it's pretty clear to put the limit of that integral, which started for x equal to 0 up to x equal 152. But how can we find the area of the cross section? The question said that the area of cross section is area of square, and we know that area of square equals side square. So for that square, I have one clear side, this side. which is passes through 2 points. The first point is x and y. The second point is x and negative y. So the length between them vertically means that I have to subtract the upper minus lower. So the side of the square, which is cross section already for the pyramid, equals y minus y, which is equals to y. But we know that we are going to make the integration in terms of x, so I cannot put the integer y at the integration. So I should find a relation between x and y. The easier way to find a relation between x and y is to use that straight line. We have a straight line passes through 2 points, 0 and 115 and 152 and 0. So it's easy to find its slope. We know that y equal mx plus p. M is the slope and b y-intercept. I should find the slope of the line. We know that slope equals delta y over delta x. M equal delta y over delta x. So delta y regarding to the given 2 points, we have the first point, which is 0 and 115, and the second point, which is 152 and 0. y2 minus y1 equal negative 115 over x2 minus x1, which is equal to 152. So already I found the slope, and y-intersect b equals 115. So the equation will be equal y equal to negative 115 over 152x plus 115. But we know that the side of the square equals 2y and the area equals side square. So I can write area of cross section equals 2y to the power 2. Area of cross section equals 2y to the power 2, which is equal 4 multiplied by negative 115 over 152x plus 115 squared. And it will be very easy to find the volume of that pyramid. The volume will be equal to the integral. Let's check again. X started from 0 up to 152, from 0 up to 152 for area of cross section for negative 115 over 152x plus 115 squared dx, and I think it's very easy to find that integral. By the same way, we can solve that question. The question said that use the integration to find the volume of a right cone with the diameter 4 cm and the height 6 cm. So again, let's consider that the x-axis inside that cone, this is the x-axis, and that will be the y-axis. The height of the cone is 6 cm, so it will stop at 6 and 0. Its base is 4 cm, so if the x-axis came inside or came at the middle of that base, because it's a right cone, it will divide it into 2 parts. This one will be 2 cm, so the coordinate for the first or for the upper point will be 0 and 2, and the coordinate for the lower point will be 0 and negative 2. So we have 2 lines for the vertical cross section. So let's check the cross section here, which is circle. The cross section is circle. I have a circle there. This will be the cross section. If you look again to the radius for that circle, r will be equals y, because if you have any point here, which is x and y, so this will be the y coordinate, so the length of radius r will be equals y. So area of cross section will be equal to area of circle equals pi r square, which is equal to pi y square. But the cross section is perpendicular to x-axis, so I'm going to use the integral dx. So I have to find the relation between x and y to substitute y in terms of x. So let's refer back again to the straight line equation passes through 2 points 0 and 2. We have straight line passes through the point 0 and 2, and the other point is 6 and 0. So the slope m will be equals 2 y2 minus y1 negative 2 over 6, which is equal to negative 1 over 3. And the y intersection is 2. So we can write the equation of that straight line. Y equals negative 1 over 3x plus 2. So the area of the cross section will be equal pi y square. So I should substitute it. Area of the cross section will be equals to area of cross section will be equals pi multiplied with negative 1 over 3x plus 2 squared. So it's pretty clear to put the integral now. So the volume of that cone will be equal the integral from 0 up to 6, from 0 up to 6 regarding to x, which change it from 0 up to 6 for area of cross section. We can put pi outside the integral because it's a constant of minus 1 over 3 x plus 2 to the power 2 dx, and I think it's clear also to find that integration.